Good morning, everybody. Today I'm going to be talking about adding, subtracting, and multiplying polynomials. Okay, so we're going to start off with looking at the anatomy of a polynomial. And because we've been doing quadratics, I'm going to look at a polynomial of degree 2. Okay, so a polynomial is anything, it's here, let me just give you this one. So this one right here is a polynomial. It is in standard form because it's listed from highest power to descending power. So here, the highest power is called the degree. Okay, and that degree is 2. That's the highest power set here. So a polynomial is variables of multiple powers joined together through addition. Okay, and each has a coefficient. So this is called a coefficient. And I hope I spelled that right. This here is a coefficient. This here is a coefficient. And there's a variable, and it can vary by power. So we must understand here that this here, the ax squared is one line term, the bx is another, and the c is another. So understand what I mean by that, because we're going to begin. I'm going to jump right straight into addition of polynomials. Polynomial addition. So if I ask you to, let's say I have 5x squared minus 7x minus 12, that's one polynomial, and I'm going to ask you to add it to another polynomial. Say I have 3x squared minus 10x minus 8. Okay, so notice that I'm going to go ahead and know that these two right here are like terms because they have an x squared on both. And then these two right here are like terms because they're the ones that have matching variable and matching power. And then these two right here are like terms as well because they are also like terms. They don't have variable attached to them. So in understanding this, we recognize now that I'm going to be able, because it's addition, I'm able to use commutative and associative property. That means I'm able to group things together by like terms. So that's exactly what I'm going to do. So I'm going to go 5x squared plus 3x squared, because that guy and that guy I grouped them together. And then I have negative 7x and a negative 10x. And then I have a negative 12 and a negative 8. Now notice that negative 12 plus negative 8 is the same thing as me saying negative 12 minus 8. That's why, in addition, I'm able just to list them like that, and the minus and doesn't affect. But when I start doing subtraction, it will. So be careful with that. Okay, so now I'm going to go ahead and join them. So here, remember, when I add, the power doesn't change. The power stays as is. In addition and subtraction, I'm not doing anything to the power because it's a joining of coefficients. So 5x squared plus 3x squared is the same thing as me saying I got 5 apples and I got 3 more apples. How many apples did I have now? Just 8 apples. Not anything an apple twice as large. So here the power stays the same. So this is going to give me 8x squared, negative 7x minus 10x. So watch, that's the 2-line rule right there. So that's why, and then watch the 2-line rule here. So negative 7x plus negative 10x gives me negative 17x. And then negative 12 plus negative 8 gives me negative 20. So again, remember, this is now my final answer. And my polynomial is in standard form because the highest power is listed first and then it's in descending order. Okay, now let's look at what happens when we do polynomial subtraction. Okay, so polynomial subtraction, you need to remember to distribute the negative. Always, 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 always. And exactly what I'm going to do is I'm going to showcase it with this first one. Instead of doing a plus, I'm now going to do a minus. So okay, so I must distribute the negative. So I'm just going to put here, always remember to distribute the negative when we're doing subtraction. And what does that mean? That means there's an invisible 1 right here, and really it's a -1. And that guy is going to be affecting this guy here, and this guy here, and this guy here. So every single term in the second polynomial will be affected by this factor of -1. So I should see, I'm just going to write this out by itself. So I have 5x squared minus 7x minus 12. A -1 times a positive 3x squared gives me -3x squared. A -1 times a -10x gives me a positive 10x. And a -1 times a -8 gives me a positive 8. So now I've distributed the negative, and now in essence, this is now going to look like a polynomial addition. So I got to make sure that I visualize who combines with who. And then we're going to go ahead and group, just like I did here. So I now have 5x squared and a minus 3x squared. And notice that I checked off every time I used it, because notice you have a lot of things going on here. So every time I group, I check off so I make sure that I don't miss anything. And then I have a -7x and a positive 10x. And then I have a -12 and a positive 8. And I make sure that everything is checked off. And now I finalize by simplifying further. 5x squared take away 3x squared gives me 2x squared. -7x plus 10x gives me positive 3x. And -12 plus 8 gives me -4. Again, my answer is in standard form. My highest power is listed first, and then it's in descending order over that. But notice I took the two same polynomials that I had added, but this time I subtracted it, and my answer was very different. So with polynomial subtraction, we must always remember to distribute that negative by doing this little step right here. Okay? Okay, so now moving on to multiplying polynomials. And the good thing is you already know how to do this. Because we just use the box, also known as an area model. So the box is the equivalent of an area model. Okay, so let's say I have, let's say I have 4x squared plus 2x minus 3 and 3x minus 4. Okay, so again, notice I have a polynomial here of degree 2, and it has 3 terms. And over here I have a polynomial of degree 1, because this is to the highest power is 1, and it has 2 terms. So this one's called a binomial, and this one's called a trinomial. Cool, but poly means many, so that's why it's umbrellaed under that. So watch what I'm going to do. I'm going to do an area model. And it's just really an extension of what we already know how to do with the box. So I have 4x squared plus 2x minus 3, and I have 3x minus 4. Make sure to always include these little signs. They are really important, okay? So now I have, that's going to give me 12x to the third, because 4x squared times 3x squared gives me 12. X squared times x gives me x cubed. 3x times 2x, positive 2x, gives me positive 6x squared. 3x times -3 gives me -9x. 4x squared times -4 gives me -16x squared. -4 times positive 2x gives me -8x. And -4 times -3 gives me positive 12. Now, if you notice, all of my like terms are diagonal. See that? So now I'm going to add them. That's what we just did previously. So now I'm going to add the inside. I have 12x cubed, negative 16x squared, positive 6x squared. So again, visual little check and balance. Negative 8x, negative 9x plus 12. Okay, now everything is already grouped, so I just have to simplify further. This guy doesn't have anybody to combine with because it's the only one to the third power. So that's going to give me 12x to the third. Negative 16x squared plus 6x squared gives me negative 10x squared. And then negative 8x minus 9x gives me negative 17x. And then plus 12. Plus 12 is on its own, nobody else to combine with. And so now, if you notice, when I multiplied, my polynomial went from a degree of 2 times 1 to a degree of 3. So now I have a degree 3 polynomial because that's the highest degree, still in standard form because it's in descending order, but now it has 4 terms. Okay? Let's go with one more example because I need to make sure that you do not do this mistake. So I'm going to see if I do x minus 7 squared. So x minus 7 squared is not x squared plus 49. No, 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 no. First, we need to expand this. X minus 7, x minus 7. Awesome. And from here, we're going to do the box. Same process. Okay. So I now have x minus 7, x minus 7. And if I look at this, I get x squared minus 7x minus 7x plus 49. So this gives me x squared minus 7x minus 7x plus 49. Okay, so this gives me finally simplifying this gives me x squared minus 14x plus 49. This is the final answer. If you notice that negative 14x, a lot of people just look, oh, it's just squared, x squared plus 49. Nope, you need to use the box to make sure you recognize that middle term. Okay, I hope you enjoyed this, and make sure you reach me out for Zoom office hours. If you have any questions, complete your assignments. Miss you guys. Stay safe.